Hello, boys and girls. We are going to be learning about light in our new science unit. So we have a beginning of a pretty short little unit on light, and then we'll start a short little one on sound and how it is that they are perceived by us. So this is going to tie right into our study also of the human body, including our eyes and ears and how they allow us to see and hear. So if you have a little flashlight, if you have a prism, I've got a prism here. We're going to talk about what prisms allow us to do. This would be wonderful to accompany you in watching this video today, but also as we continue this unit. So some of you might even have like laser pointers. I hope that you'll be able to utilize these, anything that you might have on hand in our lessons. As usual, we'll also have some extra videos for science that hopefully will bring these things to life, especially if you don't have some things on hand that could help you. So, what is light and how are we able to see it? Now, green grass, blue skies, yellow daffodils, red tulips, magenta sunsets, beige sand, gray clouds. We've got color all around us. In just this room, I've got a black coat here and some paper trays, orange and blue, the colors of the flag up there. Now, what is color and how are we able to see so many different colors around us? Now, to understand color, we must first understand light. Now, light is a form of energy. It enables us to see the world all around us. Light emitted from the sun enables us to see everything that we have on Earth. Light emitted from fires and light bulbs enable us to see at night. And also in places that just might lack sunlight. For example, I'm in a classroom right now that doesn't have any natural sunlight, so there's only artificial, which replicates it. Now, the sun and a light bulb are some common sources of light. These sources of light, as with many sources, normally emit white or almost white light. You may think of white as basically being no color at all, just colorless. However, white light actually has all of the colors. It's a well-balanced combination of all the colors we can see, from red to violet and all of the shades of the rainbow. Now, light travels in waves and can be described using what we call wavelength. One wavelength is the distance between the crest of one wave and the crest of another wave. Okay, so the wavelength is what the distance is between the crest, which is the top of the wave, and another crest. That's the wavelength for light. Now, one wavelength is the distance between those two crests. The longest wavelength of visible light is seen as red. Okay, so red waves are longer, which means there's more space between the crest of the wave itself. Obviously, we can't tell a difference when it reaches our eyes. We don't perceive light as specific ones being longer than others. And now the shortest wavelength of light is violet, like a purple. White light is made of a balanced combination of waves with varying wavelengths. Since it has all of the colors in it, there's also a combination of wavelengths. Although light travels as waves, it is emitted and absorbed as tiny portions of energy. The size of each portion depends on its wavelength. A portion of violet light contains more energy than a portion of red light because the wavelengths are shorter. There's less distance. So it's more energy. It's kind of compact, if you can think of it that way. The energy in a portion of ultraviolet light carries so much energy that it can destroy molecules in our skin. So we see that abbreviated often as UV rays, UV waves. So ultraviolet is especially dense and especially compact with lots of energy. And that's why we wear sunscreen, to protect from those ultraviolet rays. Now, the energy in a portion of red light is a lower energy light than violet light. We've got a table that I'll show you in just a moment with some common colors in their respective wavelength. And the unit of measurement is a micrometer, which is 1/1,000,000th the length of a meter. So we often talk about centimeters and millimeters, but a micrometer is even smaller. And it's a form of measurement in the metric system, but we would not use that for everyday things we have around because we can't see something that tiny. It would need to be something like this that's studied not just with our eyes. So red is 0.7 micrometers. Okay. And I'll just put M for micro M so that we can differentiate between mm, which is millimeters. We're going to get into this in math very soon. Now, yellow is 0.6, so less than 1 micrometer, the distance between the crests of these wavelengths. Blue is 0.5. And violet is the one that's the shortest, which means it has the most energy at 0.4 micrometers. Okay, so red is the color with the longest distance, the longest wavelength, less energy. Violet is the one with the most energy. Now, some of you might have a prism at home. I've got a little tiny one here. And we'll still be able to use it a little bit in this video. But if any of you have it at home, obviously that would be even better. Ask your parents if there's anything at your home that you might be able to use in place of a prism too. Like a CD or DVD, actually, that type of disc would be able to show what I'm about to do for you now. So using prisms, white light can be separated by all of the colors of the rainbow. Tiny water droplets in the air can act like tiny prisms to separate white light from the sun into the visible spectrum. So inside that one raindrop, you're able to see all of the colors that are truly in white light. And when this happens, we see a rainbow. So after a big rainstorm, oftentimes we have that rainbow because of those natural prisms of the raindrops. Now we're going to use a prism to separate white light and demonstrate that white light consists of all the colors of the rainbow. And it would be best to turn off the lights and shine light from a flashlight through a prism, but instead it's going to be able to be seen just by pointing it at the light from the ceiling. So, and once again, if you have a CD or a DVD at home, this could also do the trick. Okay, so if I was able to do this earlier. Let's see, what did I do? Sorry, I'm trying to figure it out with the camera. So it needs to be, sorry. Let's see. Maybe it's just not far enough. There we go. It's actually when it's further away that you're able to see all of the colors. Sorry, it's not, I'm trying to figure out what I had done earlier to capture all of the colors. There's unfortunately a little fingerprint there. But this prism is able to separate all of the colors that are in this light, which just appears like white light from the ceiling. But it's separating them all out. So you can see every color of the rainbow. And that is just lighting up from the light itself in the ceiling. Anyway, that still shows it pretty well. So white light going through a prism, and not all of them are flat like this. Some of them might look like a little pyramid. Basically, it's white light going in through one side of the prism and then just going out in all of the colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. So I'd love for you guys to try this out at home. If you have a real prism, that would be great. If not, a CD or DVD, some sort of disc, shining it against the light, and just practice, play around with it, different angles, just like I was doing here. It's hard to get it to show on camera. Like, I do have this flashlight here, but it's not going to show up on camera for you very well. But it'd be great for you to try that out on your own. Now, when using a prism or CD, it might be helpful to think about Isaac Newton, who was one of the great pioneers of the science of optics or visuals. Newton is the one who proved white light consisted of all the colors of the visible spectrum. He used a prism to split white light into its component colors, and a second prism to blend the discrete colors back into white light. So you had one to separate the light, and then the other one to combine them all together to become white again. So it might be fun to try that on your own if you have either two discs like DVDs, or if you have two actual prisms, to go from splitting them up into all the colors and then another prism to combine them all again. I only have one here with me at this moment, so I can't try that out. So I hope that you guys will enjoy this unit. We'll continue learning a lot more about light. But that is all for today's lesson. There's just a little bit of notes, and you'll be drawing some pictures to go along with this tomorrow. But I will make that available for you now, so that if you want to, while it's still fresh on your mind, write about what we've just talked about, you are able to do that immediately. I hope you all have a wonderful afternoon. I'll talk to you soon. Bye.